Welcome to the lecture course CHO 351 for MSc-II organic class. In previous lecture, we have discussed about the mass fragmentation of alkene and cycloalkenes. In this lecture, we are going to discuss about the mass fragmentation in alkynes and aromatic hydrocarbons. So firstly, mass fragmentation in alkynes. So in alkynes, similar to alkene, we observe the mass spectra. So here also strong molecular ion peak we can observe in alkynes. Also series of peaks like M-50, M-29, M-43, M-57, like that, so on. So that kind of peak we can also observe in alkynes also. So let us discuss with example here. Suppose one pentyne so here one pentyne, when bombarded with electron, so there is a formation of molecular ion peak. So this molecular ion peak, mass to charge ratio, so number of carbons is 5, number of hydrogens is 8, so molecular weight is 68. So at this value we can observe the molecular ion peak. After this compound, this molecule, show the mass fragmentation like this. Loss of 50 methyl group as a radical, like this, with formation of this part as a radical. So M-50, so this peak you can observe at mass to charge ratio 68 minus 50. So 53 value at this mass to charge ratio, you can observe this peak. Next peak we can observe here M-29 because of this group. This peak observed at value 39. So this peak is nothing but propanyl cation. So this peak we can observe many times in alkynes as propanyl cation at mass charge 39. Also in this compound we can observe the peak because of loss of hydrogens, means M-H. This peak also we can observe, that is the like this. So H as a radical, while other part so mass to charge ratio, that is the 68. So 67. So all this peak we can observe in alkynes. M-50, M-29 here, also M-H, and this because of proposal cation, this kind of peak we can observe in alkyne. Also, second example, 2 pentyne suppose here. Okay, 2 pentyne bombarded with electron. After bombarding, molecular ion peak is formed at the value that is the 68 here. So after this, we can observe this group loss, that is M minus 50 peak here. So this peak with radical other part. So 68 minus 50, that come out to be 53. So at this value we can observe the peak because of loss of methyl radical. Next is this group may be looked as a radical, means M minus 50. At the same value we can observe the second peak, that is CH3 CH2 plus methyl as a radical. So this peak we can observe at the mass charge goes to 53. Same value you can observe these two peaks. Also, because of loss of 29, means overall this group, we can observe this kind of peak and this as a radical. So mass charge ratio 68 minus 29. So this peak we can observe at the value 39. So all this peak we can observe in 2 pentyne. So this is about the 2 pentyne mass fragmentation. In this we can show M minus 50, M minus H peak also we can show here. That is the M minus H means 67 peak. Loss of H as a group here. Suppose from this position we lose the H as a radical M minus H. So CH2 plus, then triple bond with carbon, then CH2 CH3. Okay, and this as a radical part. So this peak mass to charge ratio 67. So all this peak we can observe in mass fragmentation of pentyne compound. So this is all about the mass fragmentation of alkyne. Next is the mass fragmentation of aromatic hydrocarbons. So next is the mass fragmentation of aromatic hydrocarbons. So here also remember that mass fragmentation of aromatic hydrocarbon, in that we can observe that strong molecular ion peak, intense molecular ion peak we can observe. Suppose if you consider the example of benzene. So let us discuss with example of benzene. So benzene, so bombarded with electron. After bombarding with electron, we can observe the molecular ion peak like this. So here this loosely bound pi electron is ejected from molecules. we can observe the molecular ion peak at mass to charge ratio. We can calculate that is C6H6. So 12 into 6 into 6. 12 into 6 is nothing but 72 plus 6, that is 78. Molecular weight of this compound is 78. So at that value we can observe the molecular ion peak. So from 78 we can observe the peak, that is the loss of hydrogen, M minus H. So from any position, if you lose the hydrogen as a radical, we can observe like this peak positive charge here. Mass to charge ratio, this peak we can observe at 77 with H as a radical. So this part as a radical and this peak we can observe in benzene 77. Also after 77 peak we can show the here loss of acetylene like this. Loss of acetylene means loss of M minus C2H2. M minus C2H2 means M minus 26. This much we have to lose here. So for this we can write like this. So this lose, this 1 and 2, this is lose as a acetylene molecule plus this also as a radical. Okay. So again from this we can show the rearrangement like this here. This one electron and this one electron combine here. So this hydrogen, this carbon is combined here, and this electron, this one electron, they combine, and because of that, we can observe that here triple bond with hydrogen, and again here double bond as it is will become like this. So this type of protonate glutamine we can observe. So this peak we can observe at mass to charge ratio, that is the 77 minus 26 at mass to charge ratio 51. So at this value 51 we can observe this peak. So in this way we can show the mass fragmentation in benzene molecule. Next molecule is a toluene. We are going to discuss here. Toluene, when bombarded with electron, after bombarding with electron, molecular ion peak, mass to charge ratio 92. At this value you can observe the molecular ion peak. From this, we observe the M-1 means here M-1 mass to charge, that is 91, that is the because of H as a radical. So this is the because of benzelium cation, we can observe this thing. So here we show like this rearrangement. So this benzelium cation when undergo rearrangement, we can observe the get 7 numbering. Okay. After rearrangement, this CH2 carbon, this neighboring carbon is acquire the positive charge. Okay. Like this. Okay. In this will be the numbering. Suppose 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. So in this way carbon is rearranged. So this is same mass to charge, so that is 91. So this cation is called troponium cation. Troponium cation. So we can call troponium cation this. So this is this troponium cation. After that, this troponium cation lose the acetylene molecule. So after losing acetylene molecule like this, we can write like this: loss of 26. From this we can write the M-26 loss, M-C-II H2 loss. So when this part is loose, in 5 and 4, carbon number 5 and 4 lose as a acetylene. 5 and 4 lose as a acetylene, while 6, 7, like this. And this part radical, this part also radical. So this part is combined. After combining this part, we can observe that like this: 6, 3, 2, 1, 2, 1 and this is 7. So this type of cation is formed. This cation is formed at mass to charge ratio 26 minus 91 minus 26 is nothing but 5, 6. So this cation is formed as the mass to charge is 65 value, and this cation has the name, that is the cyclopentyl cation. This cyclopentyl cation further lose M-26 M-C-II H2. So you have to look this part as a acetylene molecule. So when this carbon number 6 and carbon number 7 is used as a acetylene molecule, okay, the remaining part 1, then 2 and 3, 1, 2 and 3. So this is a radical here, also this is a radical. So these two radicals further combine, and this is nothing but like this. Here this is a positive charge. So this one, 2 and 3. So this mass to charge ratio. So 65 minus 26. So that come out to be 39. Add this value. This cation has a name, that is cyclopropene cation. So in this way we can show the mass fragmentation in toluene compound. Toluene compound show the peak, that is at the value mass to charge ratio 92 firstly because of molecular ion peak. Molecular ion peak lose the hydrogen. We got the benzene cation, that is also known as the troponium cation 91, 91. After that, you have to lose the 26. 26 losing, we got the 65 cyclopentene cation, that cyclopentene cation further to the 26, that is the 39, that is cyclopropyl cation. So all these cation have to show during mass fragmentation of toluene compound. Next compound, that is the xylene. We are going to discuss it, the xylene compound. Next molecule which is coming in aromatic hydrocarbon, it is xylene. Suppose we consider the xylene. Okay. Structure of xylene is like this. When this molecule is bombarded with electron, after bombarding with electron, we can observe the molecular ion peak at mass to charge ratio. Molecular ion peak at mass to charge ratio. So this value is nothing but 106 here, molecular ion peak. So when this part is used as a hydrogen as a radical from any group, suppose we can observe the peak at 105 and yes as a radical. So here we can show this kind of rearrangement to show the methyl troponium cation. So this is the 1, 2, 3, 4, 5, 6, 7. Okay. So because of that, this becomes 7 numbering. This is a CH2, carbon number 1, carbon number 2, 3, 4, 5, 6, 7. This is attached to 1, 6, 7, okay, 4, 5, like this. And this will be attached to carbon number 3, like this. So this cation is named as a troponium cation, but which will be attached to be called methyl troponium cation at mass to charge ratio, that is 105. So in this way we can show the peak at 105 for methyl troponium cation. Also, we can show the peak here because of M-50. Suppose one group is loose here, methyl group as a radical, we can write like this: CH3, CH3. So this cation is the observed at mass to charge ratio, that is 91. 91, we can observe this peak because of methyl as a radical. So here also we can show the rearrangement, same like above case. Like this. In this way we can show the benzene cation, this. So here simply hydrogen is shifted at this position, migration of hydrogen is up at this position because that positive charge is coming at this position. So in this way we can show the rearrangement, and simply same like above cases we can write here 7 member. This is the benzene cation, you know, benzene cation. This benzene cation observed at mass charge ratio, that is mass charge ratio, that is 91. No doubt about that. When you show this rearrangement, this will become 7 member ring again. So this is suppose CH2 group. So its neighboring carbon become positive charge, like this. Suppose you give the number 1, 2, 3, 4, 5, 6 and 7. Okay. So 1, 2, 3, 4, 5, 6 and 7, like this. So in this way we can show the numbering to the carbon. So after this is called the troponium cation, we call mass troponium. Troponium cation, that is the mass to charge ratio, that is the 91. You have to remember, that is 91. So from this troponium cation, we can show the loss of acetylene. So we can observe the peak at mass to charge ratio at the value 91 minus 26, that is nothing but 65 as the cyclo pentyl cation. Cyclopentyl cation further lose the acetylene molecule C2H2. We can observe the peak at mass to charge ratio, that is 39, because cyclopropyl cation, same like toluene compound, we can observe the same kind of peaks, not different kind of peaks. The troponium cation 91, after that acetylene molecule is loose, we can observe the cyclopentyl cation 65. We have written the same kind of fragmentation in toluene compounds. After this troponium cation, we have written cyclopentyl cation 65, also cyclopropyl cation 39. So in this way we can show the mass fragmentation in orthoxylene compound. Also we also write for the metaxylene, then paraxylene, same kind of mass fragmentation we can write for the orthoxylene, paraxylene and metaxylene. So remember that 106 molecular entry, 105 methyl troponium cation, the loss of methyl group 91. For that we also write the benzene cation, troponium cation, from that we can write the 65, 39. So this is all about the alkynes and aromatic hydrocarbons.